Robotics, artificial intelligence and the systems that drive them are drastically changing the world we live in. From the factory floor to outer space, robotics is essential in optimizing industry, saving lives and bringing people together. Now in Macau, China, robots are connecting people in more ways than one as researchers, educators and practitioners in robotics meet for the world's most important robotics event. From autonomous driving to marine exploration, drone swarming to medicine AI, it's all here at the 2019 IEEE RSJ International Conference on Intelligent Robots and Systems. And you can catch it all here on IROS TV. It's day 3 here at the Venetian Macau and things are really getting underway. We've had technical session after cutting edge forum, plenary after keynote, all with the very latest in robotics and AI. We've got plenty more for you today as we take a look at how robots are becoming ever more human, from human level intelligence to robots working alongside humans. Let's take a look at what's coming up.
So wouldn't it be cool if your robot could give you a high five after it delivers you your medicine in the hospital or after it helps cleaning up the kitchen?
Reaction that we get with our robots when we perform a magic trick is often quite magical in itself, because people are like, how did the robot do this? That's incredible.
Most of the robots are made by us, roboticists, engineers. We're good at making robots that have are robust or powerful, but we're not good at making robots that are actually useful for the people.
Humans are complex and our interaction with robots can be somehow unsatisfying. So to take a better look at how we can optimize that human interaction with robots to make the experience smoother and more effective, absolutely delighted now to be joined by Professor Gentiane. Professor, welcome.
Thank you very much for inviting me.
So what are the limitations today with human interaction with robots?
Well, we do have a lot of robots that we can see here at the conference and the exhibitions and everything. But these robots are more like industrial robots or robots to be in industrial settings or very closed settings. They're not really interacting with humans, and when they do, they don't have a lot of functionalities. So we still have hardware limitations that we need to overcome. So industrial robots is something on the side, but we're building robots or said like social robots, but they don't have any social function, or they don't do anything, and so they're basically just like empty like shells and boxes. Yeah.
And what's the problem when we try and design those today?
Well, the problem when we're trying to design those is that like most of the robots are made by us, roboticists, engineers, and we are good at doing like technological stuff. We're good at making robots that have are robust or powerful or but we're not good at making robots that are actually useful for the people. Indeed.
Well, give me an example of that.
So for example, like the robot Pepper that we're using a lot in our lab, and I'm very grateful for Sovereign Robotics to have made that robots, is a very affordable like robots, but it's a big platform. And when you have it in your living room, it is too big for the few functionalities that it actually has. And when you have it in social or like public spaces, it usually has too weak in terms of like sensing abilities and communication abilities. And so basically it's a very fancy tablet holder.
Okay. And what's the answer? How do we design better robots, more fulfill our kind of social needs?
So I think there is a big trend now in robotics and in HRI in general, is really working in collaboration with people that are potential users of robots, designers, and people that know how to create interactive systems.
Well, give me an example of that.
So in my research, one of the examples that I have that I found the most striking is the work that we're doing with ergonomists and designers, where we're trying to understand what are the needs for the young retirees and how far the actual robots are from their ideal robots. And when they create these ID robots in their mind, how when they had an experience with an actual robot, they change this ideal to something that is more probably realistic. Because science fiction movies and imagination has created these amazing, like, almighty robots, and everybody wants to have an almighty robot that is like tiny, powerful, intelligent, and cute, and sensitive. But in the other hand, we have, for example, Pepper, which is like a very bland white box of plastic, quite giant in your living room when you have a tiny house, and it does pretty much nothing except like stare at you. And like, of course, we program it to be a little bit more intelligent than the regular Pepper, but it's still like not perfect, right? And if you ask like, Pepper, can you give me a glass of water? It's just like, I'm sorry, I'm too weak to give you a glass of water. And I don't know where is the glass of water, and I cannot turn the tap on. Okay, thank you.
So what are the next steps then in bridging this gap?
So the next step now is that we have collected a tremendous amount of information about these robots, ID robots that people want to have. So we're now prototyping new robots that are smaller than Pepper, and we will conduct the same type of experiments again to see how people like it better than Pepper, and if it fits better if it matches better their expectation of the ID robots.
Well, thank you very much indeed for talking to us today. Really appreciate it. It's fascinating stuff, so thank you.
Thank you very much.
Next to IIT in Genoa, Italy, with more on human-robot interaction, as well as a wide array of other robotics research areas, from dynamics-legged systems to exoskeletons and so much more.
I think robotics will play a very important role in the future. I see robots in healthcare allowing, for instance, surgery to be very precise. I see robots in case of disaster intervening to save human lives. In robotics, we have mission to help and empower humans. And therefore, everything we do has the human in the center. IIT, the Istituto Italiano Tecnologia, it's a research foundation. We do material science and nanotech. We do robotics, of course. We also do life technologies, which is biology and possible applications to healthcare. We have a very large program in robotics. There are more than 350 people. We cover the entire design process. We go from the mechanics, the electronics, but also software. It's very diverse, but in a sense, we're developing this family of robots, each one tailored for a different sector. In the Advanced Robotics Group, we develop robotics for biomedical applications. This comes in two flavors. One is surgical robotics, and for rehabilitation. Here we develop exoskeletons or prostheses. We're developing exoskeletons also to help human workers in the factory. We're doing, for instance, quadruped that can be deployed in case of disaster. We're also developing humanoids for the same purpose, so that the humans can be safe while the robot can carry out a particular task.
The whole purpose of legged systems is to go onto environments where wheeled and tracked vehicles cannot go. The most recent version of our robot is called HiQ Real. And to demonstrate its power and its nice design, we brought it to the airport of Genoa so that it can pull a 3.3-ton airplane. All our robots are driven by hydraulic actuators. The hydraulic actuator has a very high power density and can cope with impacts very well. One of the grand challenges of legged systems is how to place the foot on a correct spot. So we have developed an approach in which footholds can be selected and corrected in a very fast way.
At the moment, our focus is industrial robots. They can be fixed-based or mobile-based. Mobile robots can be just like humans, going around, doing some scanning, understanding and responding to the needs of the people. We recently created MOCA, which stands for Mobile Collaborative Robot Assistant, the integration of a robotic arm and mobile base.
The more you bend your body, the faster the platform will move.
We are trying to introduce these systems in industrial applications to see who is the co-worker that they are supposed to work with, to respond to their intentions and needs, both physical and social, and eventually to improve their ergonomics of working. It's a revolutionary thinking of improving productivity in industrial environments that are dynamically changing.
Ciao, Eka.
Ciao.
We look at how biological systems work and try to develop technology and integrate it into robots to make them fully autonomous. We look at neuromorphic or event-driven types of sensing devices for vision and integrate them on humanoid platforms. We're mostly using the iCab robot to improve its interaction with the external world. The idea is to integrate also neuromorphic computing devices to give autonomy to the robots thanks to low-power devices, very efficient computation that is more capable of extracting information from the external signals.
We don't really yet understand the mechanisms that the human brain uses during interactions with others, humans or artificial agents such as robots. We try to address that with scientific methods. The project that we're working on is focusing on what sort of conditions make humans attribute mental states to the robot and make humans attuned to the robot. We try to tap onto very implicit and subtle mechanisms of social cognition. The way to measure for us is to use methods such as eye tracking or EEG or reaction times in a task. We actually need to work with roboticists, developmental psychologists, cognitive psychologists, social psychologists to develop paradigms and address the questions that we are trying to address.
IIT has, let's say, a double mission to do research, but also to transfer technology to the market. We're doing startups, but we're also patenting. We have a number of joint labs with companies where we're developing new robots, and we have collaborations with hospitals to deliver the robots to the healthcare sector. I think robotics is amazing. First of all, it's our flagship project. We have brilliant researchers that are really working at the forefront of research in robotics.
One of the, I think, most positive points about IIT is that you know a lot of people with different backgrounds, with different expertise. We actually impact each other's work as well, our own research.
It's a very, very unique environment, given the possibility of having interactions between disciplines. I don't think there's a better place on Earth.
Now for another technological masterclass as we take a close look at the development of human-level AI for robotics. To tell us just how close we are, I'm delighted to be joined by Professor David Vernon and Dr. Shingo Shimoda. Gentlemen, welcome.
Pleasure.
So we're talking about AI in robotics. So how close are we to having a human-level intelligence?
Not as close as we'd like to be honest with you. We know what we want to achieve. And we can achieve a great deal in robotics today, but achieving the versatility that a human being has in their ability to deal with uncertainty and the unknown around them is something still of a reasonably far goal in AI.
So how important is it that we work towards that goal?
One of the important purposes of robot researchers is want to be a friend with robots, also sharing many tasks and helping each other. For that, AI is very simple word, but cognition of the task or sharing and such kind of one is much more important. Not a simple AI, but much more complicated with interaction or sharing tasks or such kind of one.
Tell us a little bit about the work that is happening here at IROS.
So we're organizing a cutting-edge forum, effectively to answer your first question. Where are we today in terms of achieving this goal that we've had for the last 63 years of achieving human-level intelligence in robotics? And we're going to be looking at some of the state-of-the-art that's been done in Europe and around the world. And we can do things which we couldn't do 10 years ago.
Right.
And we've moved robotics out of the factory into the home. And that's where we are today. So some of the things that we'll be talking about show robots working in a kitchen, for example, just doing menial things that humans find easy, but are not necessarily easy for a robot to do.
What was very difficult 5 years ago that you can do now?
Two things have happened. One is our computer vision facilities, our capabilities have improved greatly. Our vision is much better than it was 10 years ago or even 5 years ago. The second thing is we've learned how to bring a lot of common sense knowledge in and factor that into the reasoning and the way that the robots go about it. So now you don't have to program everything in. The robots can learn for themselves as they experience the world and as they go about doing things in the world.
You brought these great examples with you, so maybe you could take us through them.
Yeah, sure. This is an example from the work of Michael Bates in the Institute of AI in the University of Bremen. It's a nice example because it shows difficult robotics tasks being done by a PR2 robot. It seems simple to you and me, right? But the problem is that it doesn't necessarily know what these things look like. It certainly doesn't know where they are, and it has to figure these things out. So it has to be able to reason about the world around it. It also has to be able to anticipate what will happen when it does something.
Right.
When you and I work in the world, everything that we do, well, what would happen if I did that?
Right.
And that's not been the way we've thought about robotics today, but that's the key to cognitive robotics, is continually anticipate the outcome of the actions and the need to act. And that's what this work shows you can do now.
Okay. So what does the future look like? Where do we go from here?
This kind of robots can help us, but we to share, so live together, much more we need the interaction also, not only just sharing a task, but interaction, helping each other. This kind of mechanical interaction and this kind of task sharing. Complete one task together.
I think that we're going to see robotics become more part of our lives. And as you said, they're going to become a seamless part of what we do. But we need more research. And the research has to be not just at the applied level, it has to be at the fundamental level as well. But I'm incredibly optimistic about the future. I'm looking forward to working in it for a lot longer.
Well, gentlemen, thank you very much. Really appreciate it.
Thank you
very much. Appreciate it. Thank you. Over now to the University of Maryland and the Maryland Robotics Center, where they're working hard on their mission to advance robotics systems.
The main mission of the Maryland Robotics Center is to advance robotic systems, the underlying component technologies and applications of robotic systems through research and education that is interdisciplinary in nature and based on a systems approach.
We have a great variety and diversity of talents and specialties that we have here. Many labs from different aspects of robotics.
The Maryland Robotics Center consists of over 40 faculty, a number of unique facilities including the Unmanned Aerial Systems Test Site, the Fearless Flight Facility, and the Neutral Buoyancy Research Facility.
The Fearless Flight Facility is an outdoor netted facility that we have close to campus. We are located within the flight restricted zone here in DC, so we do a lot of test flights out there.
Today we are here at the Fearless Flight Facility, where we have multiple quad rotors which are taking off. They're using synthetic flight data to complete this map and search mission. As they explore the environment, they use the idea of mutual information to guide their search.
The eReeb Drone Lab is a brand new shared lab that allows us to study aerial robotics using motion capture cameras.
My work in drone racing involves a lot of integration. It starts with the hardware in terms of building a drone and getting it to fly, integration of sensors and getting that connected to the drone itself, and then a lot of programming. We try to figure out what the camera is seeing and try to integrate that with the drone itself.
We try to think of robots, whether they are one or several, as a system. And we try to have this wholesome approach to the design of the robots, to the evaluation, and so on and so forth. And that's kind of unique. All right? So one example is this. I'm trying to design robot arms. Can you do the design before you go create a single screw? That's how we do airplanes today, but we don't do this for robots. So there's a little bit of a strange thing here, right?
In the Bio-Inspired Advanced Manufacturing Lab, or the BAM Lab, we try to use micro and nanoscale 3D printing technologies to solve biomedical challenges. And so in the context of robotics, we're trying to create an entirely new generation of soft prosthetics that are built using 3D printing. The way that we build our soft robotic systems is that we use a special type of 3D printing. And what makes this type of 3D printing special is that it's just like a color printer, but instead of printing just one page, we're printing multiple pages, one on top of another. And what makes it great for soft robotics is that we can print different types of materials, like soft, flexible materials and hard plastic materials that are fully integrated, so that after the printing process, in a single print run, we have something like this.
The Buoyancy Research Facility is the largest underwater research facility on a university campus and the only one equipped with underwater motion capture. This is where we study autonomous underwater robots and space systems using the underwater domain to simulate microgravity.
What we have here is a tank that's 50 feet across and 25 feet deep, and we use it to simulate space. There are only 6 tanks like this in the world. This is the only neutral buoyancy facility in the world on a university campus, and it's one of only 2 active facilities in the United States. We're very pleased to have this unique facility. We put our robots in the water. We actually put people in the water, either directly as if they were inside a habitat or wearing spacesuits. We're actually developing robotic systems that operate in many different environments to try to ensure that we can have the technology available as we advance outwards into space, that we'll have robotic systems ready to go along with the humans. One of the unique things about this laboratory is everything you see here is designed and built here almost entirely by the students. So if you look at a robot arm like this, that was originally developed to fly in the space shuttle, it was developed by students, and we still operate it using graduate students and undergraduates. We try to involve students across the spectrum, from freshmen all the way through seniors, graduate students, and get them all involved in the engineering development process.
I'm only a small part of this, so I'm a faculty advisor, which means that I sit in my chair and really think up cool ideas, and then the students are the ones who are actually executing. So they're the ones who actually know what's going on, how to fix things when I break them, and actually are the ones who are executing.
Here in the lab, we have 4 faculty from computer science and engineering who work here. We have postdoctoral research associates that they work here. These are people that already have gotten their doctorates. We have graduate students, we have undergraduate students, we even have high school students. And they work in little teams, doing experiments, doing theory. The future of the center is very bright.
Come to the University of Maryland. It's a great university. You ought to go to grad school here. You ought to go to undergrad here.
Our sense of touch is essential for almost everything we do, and understanding how this works can help us better design systems that rely on it, from haptic interfaces to physical human-robot interaction. Covering it all is Professor Katherine Kuchenbecker, who looks at haptic intelligence. Thanks very much indeed for taking the time to talk to us today. We really appreciate that, so thank you.
My pleasure.
Why is touch important when it comes to robots?
Well, touch is, I think, the most underappreciated of our senses. So you can see, you can hear, you can smell, taste, and touch. Unlike the other senses, touch is distributed through your whole body, and it's driven by many different kinds of receptors. You can feel pressure, vibration, pain, stretch, inside yourself, outside yourself, the pose of your body. We really, as humans, almost just take it for granted. Right. But almost all robots that we build today have a very primitive sense of touch. They typically know where their body is in space, but they know almost nothing about whether that body is contacting the world. And thus, when they try to interact with things, say like pick up a cup, for a robot to do that well and not say crush your wine glass or drop things all the time, it really needs a sense of touch. But we're still in the very early days in terms of what makes good touch sensors in different situations for different parts of a robot's body, and how can we process that information to enable a robot to do things autonomously with objects and also around people.
So how important is haptics when it comes to remote interaction?
Yeah, actually, telerobotics, when you control a robot from a distance, was the foundation of the entire field of robotics. Right. It was developed for humans to be able to remotely manipulate hazardous things like nuclear material. The first telerobotic systems were actual manipulators, like remote control, physically linked. So they had natural haptics. You were just driving like almost like a puppet, a physical puppet around. And then when they split that and put a computer and some electronics and sensors and actuators between them, there was no sense of touch. So my team has worked a lot on different ways to bring back, to add in a sense of touch in telerobotic systems. Most of our work has been on robotic surgery, and we have designed a system that where we can add components to almost any surgical robot, say like a Da Vinci robot by Intuitive Surgical, a little sensor near the tools, one on each tool. We use an accelerometer that can measure the vibrations of contact when the instruments hit each other or hit things or cut, or even when they're not viewable by the surgeon. And then near the surgeon's hands, on the joysticks, we put a little vibration motor, and this repeats the vibrations that, say, the left and right tools are feeling, say, inside the patient's body or where they're trying to disarm a bomb or something, and let the surgeon feel that. So now when the surgeon hits something, they can feel the contact, they know how rough they're being, and we found this has an immense improvement of their ability to learn how to do tasks remotely and do them safely.
What are you working on to make that interaction between humans and robots more effective?
We work on lots of different ways to add touch into telerobotic systems. Along the way, we got inspired in several other directions. One was to give robots a sense of touch when they're manipulating through sensing and perception. And then another is to have actually human-robot interaction, not a human controlling a robot to do a task, but interacting with a person like an agent, like you and I are right now. And the kind of human-robot interaction that we're really fascinated with is physical human-robot interaction, where we just don't talk, but we might say like shake hands, so we can do this, or play a different hand clapping game. So we've built a few different robotic systems that interact with humans safely and in a physical way. Touch is super important also for interhuman connection and personal interaction. And so as more robots come into our homes and maybe try to help us do household tasks or take care of an older adult or maybe work in a hospital, they're going to bump into people, and they're not only going to need to be able to do that brushing past someone in a hallway in a safe way, but also in a polite or maybe even fun way. So wouldn't it be cool if your robot could give you a high five after it delivers you your medicine in the hospital or after it helps cleaning up the kitchen?
And you've designed a robot that can hug.
Oh, yes, actually also, we call it HuggyBot. HuggyBot 1.0 I built when I was a professor at Penn in Philadelphia, and we showed that people prefer hugging soft, warm robots, and also very funnily, robots that will let you go when you're ready to go. We program the robot to hold on too long, and people really don't like that. So obviously, it needs touch sensing so it can tell when you're ready to be released. And we're also now building HuggyBot 2.0 in Europe at ETH and in my lab at MPI. And then we're also working on a whole series of robots for exercise, where they play physical interaction games, stretching, and we have great results that are under review right now in a journal that people, both younger and older people, really enjoyed interacting with the robot in this fun, social, physical way. The robot smiles and moves its head and plays music and challenges you to reach and stretch and move fast. So quite a lot of fun. You should visit my lab.
Perfect. Thank you ever so much indeed. That was great. Thank you.
My pleasure.
Thanks. Now to Korea for more on haptics. The POSTECH Haptics and Virtual Reality Lab is focused on improving the tools software designers and 4D media makers have to accurately and effectively integrate haptics into their work.
Pohang University of Science and Technology, we call POSTECH, is founded about 30 years ago, and we are very proud of we educate leaders, future leaders of Korea and global science and engineering, actually. Department of Computer Science at POSTECH, we have 21 faculty members and about 350 students who are focusing on haptics, robotics, and IT convergence engineering and different algorithm development. We also host our National Institute of Robotics in POSTECH campus.
People define haptics in many different ways, but to me, haptics is one nice way to allow users to interact with computers and robots physically using their body and using the sense of touch. Our mission is to improve the human aspects of haptics research. So we have people from mechanical engineering to design devices. We have people from electrical engineering to system control and some other communication-like issues. We need people to make a good rendering algorithms from computer science. We need people from psychology to understand the human aspects of haptics and VR. These days, I have one umbrella theme, which I call automatic authoring of haptic content, which allows people to recode or create haptic content very easily and sometimes automatically. For instance, when you press your skin, then we want to recode its false response and recreate that response in a virtual environment. Or we can convert sound like music to tactile effects. We can analyze a video and, for example, analyze the motion of a main character. Then we can make a very nice motion effects.
I'm working on data-driven haptics, modeling and rendering the viscoelastic objects. Haptics can be used in every item we build in the virtual reality world. The more realistic the virtual world is, the more haptics is needed. Data-driven haptic rendering is a realistic haptic rendering method that simulates real-world haptic responses using many measured data such as acceleration, force, or temperatures. We are developing this technology to bring real-world objects to the virtual world. Data-driven haptics performs in 3 steps: data collection, modeling, and rendering. This can be a simple approach for anyone who wants to build the haptically immersive application.
I'm doing a research on 4D effects synthesis. 4D effects authoring is manually done by 4D effects designers. So the production of 4D contents is very labor intensive and time consuming. Our purpose is to automate this process. We investigate recent computer vision and signal processing technology. We apply them to extract audiovisual features. By extracting those features, we want to render effects representing high-level information. Also, we want to expand the application domain to other entertainments such as watching sports or games.
I'm working on the augmenting multimedia contents for the consumer electronics. The application area consists of the whole consumer electronics, from the mobile phone to a car, like a touch screen display or vibration, and even some robotic devices. We can add haptic interactions for that to improve the usability and enhance user experiences. Once the target device is decided, generally we have 4 steps in the whole procedure of our research. We decide the haptic actuator to plant into the device, and we evaluate the whole scenario by conducting a user study.
Virtual realities, including AR and VR, is quite different from other previous computing environments such as mobile computing or GUI-based computing. It gives you a lot of information about what you have in your real life or your more situated interaction. The purpose of our study is to make haptic interaction more intuitive and useful. We are trying our best to provide right information at the right timing, which helps users to perform specific manual tasks. We designed some sensing platforms to specify when to provide haptic feedback and design some haptic hardware or haptic displays to present pleasant tactile feedback.
Haptics is started as a part of robotics for like a teleoperation. From 1990s, it became a big part of robotics and in virtual reality in HCI. Still, it's immature. We have a lot of things to do to make a good haptics technology so that other people can use it easily in their daily life. So I wish more people get interested in this area and participate in doing good research in this domain.
So we all think robots are getting more human, but can they do magic or make music? To answer the question, it's time for another competition, the Humanoid Challenge.
Now, let's do some magic.
This competition is the IEEE IROS 2019 Humanoid Application Challenge. Robot Magic and Music is the theme for this year.
Cross your arms in front of you now.
We have robots performing either as magicians or musicians on stage. The goal of this competition was to provide a competition that is not strictly quantitatively judged, but to have something that is a little bit more open to interpretation and gives the teams a little bit more creative freedom.
We are the team from Canada, University of Manitoba. The main challenge of having the robots as a band is the synchronizations. We also have computer visions that works on the robots that could be able to calibrate itself to the drums and calibrate itself to the keyboard.
We are from India. We actually came here for the Humanoid Application Challenge, and we are going to play xylophone out of Humanoid bot. The bot actually is programmed in such a way to adapt to the situation where it actually plays a song.
My team is from National Taiwan Northern University, and this is our third year to participate in this robot magic show. Our robot is made from the Korean company Robotics, and we use it to develop our code. He's going to do some magic, and this is a secret, so I cannot tell you.
They look at a picture, they try to interpret the entire image in one pass, in one go. That's not how human perception works. And I think magic is a really good benchmark problem for that, because magic is all about misdirection of attention. So I want you to look here, but this is where the trick happens.
Please unveil to the audience what we've done here.
This is very new to us. We have to develop a new framework for the robots to work together. We have to make the robot be able to communicate to each other.
We want to use a robot to develop a different kind of technology. Like we can use a robot to interaction with a human.
It's all about the exposure that we get. We actually are undergraduate students. I'm currently in my fourth year, so it's a good platform to like communicate and compete with international students as well. So yeah, that's the plan.
What I like most about it is often the reaction of the audience. Of course, we need to interact with the audience, and the reaction that we get with our robots when we perform a magic trick is often quite magical in itself, because people are like, how did the robot do this? It's incredible.
See you again in IROS. Thank you. We enjoy the competition very much. This is the only day that we will compete on the stage after the travel of 30 hours from Canada. Yeah, that's a lot of fun.
That's it. That's the end of our last show here in the exciting city of Macau, with robotics and AI changing the way we live at increasingly rapid pace. It's fascinating to hear what's coming up around the corner with some of the top researchers and what they're doing, from autonomous vehicles to vision-based navigation and human-level AI. Of course, IROS 2019 lives on in IROS TV's coverage even after the meeting comes to a close and we all board that ferry home. Make sure to find us IROS 2019 website and of course on YouTube. We hope you've enjoyed the show. Make sure you get in touch if you have, and even if you haven't, and we hope to see you next year in Las Vegas.
My highlight from IROS so far is meeting everyone, different people from different countries, Italy, France, with lots of passion and interest in robotics. So seeing that common interest and be able to communicate in the same level, it's really nice to see.
Keynotes, many famous professors to give their suggestions and advice and thoughts about the robotics in the future. And yes, this is my favorite thing.
The highlight of the conference, I think, has been the presentation from Dr. Kim from MIT, the Shida robot. It was really insightful, and the research that they've done it's really impressive.
It's just great to meet so many people that are working in a similar work.
You know, a lot of the papers here are relatively academic, but people are also applying them in industry. So I think just seeing like things moving forward side by side and actually like coming to fruition with robotics is pretty cool.
I really like coming to IROS because it is a really big conference where top-notch research is presented, and it's a great opportunity for young researchers to come and do networking.
It covers a wide range of topics, so actually it's interesting to not only see people that are working in the exact same niche as I am, but like more general topics that are hot at the moment.
I think with IROS, you kind of just see everybody that's making these contributions in person, rather than having to talk to them over the phone or email. They're all right here, so anything really innovative and new, you can just go meet the people and get their thoughts very directly.
I saw the whole community of PhD students coming together and sharing the latest research. I feel like it's an incredible opportunity to, you know, have your ideas checked with the others and see where you're at compared to the state of the art. I think it's an amazing opportunity.